In this video, we're going to look at repeating decimals written into fraction form using the concept of an infinite series. So in this question, we want to write this decimal 0.12 repeating as a fraction. So remember, another way that we can write this is 0.12 with the bar over it, which tells us that it's repeating. What I'm going to do is kind of break this down and write this decimal as 0.12 plus 0.0012 plus 0.4012 6 zeros, 1, 2. So we're sort of breaking this down into each of the two digits, 1, 2, being added on each time. And then this would go on forever. So essentially what we have here is a geometric infinite series where my first term is 0.12 and my R value is 0.01. So each time I'm multiplying by 0.01 or I'm dividing by 100. And then from our rules before, we know that if the absolute value of R is less than 1, then this converges. And I can find that infinite summation by doing the first term over 1 minus R. So my first term in this case is 0.12 over 1 minus 0.1, which is 0.12 over 0.99. And then if I multiply both of those by 100, I get 12 over 99. So then I've changed that repeating decimal into a fraction of 12 over 99. And then another way to look at this is to do this algebraically. So here we're going to start with setting this. I'm just going to set this equal to x. So I get x equals 0.12 repeating. Then I'm just going to multiply both sides by 100 here. So I'm going to get 100x. So multiplying by 100 is going to move this decimal point 2 places, and I'm going to get 12.12 repeating. Then taking our original statement, which is x equals 0.12 repeating, and I'm going to subtract these two equations. So this gives me 99x equals, and then here the 0.12 repeatings will cancel out over 12, and then I can divide both sides by the 99, and we get x equals 12 over 99, which is exactly what we got before. So just kind of two different ways to look at it, so you can decide which one makes more sense to you. Just looking at some single digit values here. If we have 0.1 repeating, so this would essentially be 0.1 plus 0.01 plus 0.001, etc. So an infinite geometric summation, which would have a first term of 0.1, and each time we are dividing by 10 or multiplying by 0.1. So if we do that infinite summation again, we're going to get 0.1 over 1 minus 0.1, which is 0.1 over 0.9, or 1 over 9. So 0.1 repeating equals 1/9. So looking at the second one, doing it sort of the algebraic way, here we'll go x equals 0.2 repeating, and we'll go 10x equals 2.2 repeating. So if we subtract these, 10x equals 2.2 repeating, x equals 0.2 repeating. So this will give me 9x equals 2. And then dividing both sides by 9, we get x equals 2 over 9. So 0.2 repeating equals 2 over 9. 0.3 repeating, most people are familiar with this. So this is the same as 1/3. So if we think of this 0.3 repeating, when we had 0.1 repeating, we had 1 over 9. 0.2 repeating was 2 over 9. So 0.3 repeating would be 3 over 9, but then that one just reduces to 1/3. So if we kind of just think of this as a pattern, then 0.4 repeating is going to be 4 over 9. 0.5 repeating is going to be 5 over 9. 0.6 repeating is 6 over 9, which reduces to 2/3. Again, we're familiar with that one. 0.7 repeating is 7 over 9. 0.8 repeating is 8 over 9. So looking at a couple examples here, we want to write the following decimals in fraction form. So 7.14 repeating. So there's 2 digits repeating here, so we want to multiply by 1 followed by 2 zeros. So we're going to multiply both sides by 100. So I'm going to go 100x equals 714.14 repeating. Again, writing the original underneath that, and then we're going to subtract these. So we're going to get 99x equals 707, and then the 0.14s will cancel out, and then we get x equals 707 over 99. So using the calculator to double check that, I can see that I have 7.14 repeating.